First Spin. Welcome to First Spin, a show where I learn how to use the Parallax propeller without having any prior programming experience. And rather than do this on my own, I have enlisted the help of two experts.
Hey, everyone.
That's Whisker.
Is it last week or this week or next week?
What do you mean?
Well, we've been kind of in the future.
Yeah.
Because we recorded several of these before going to the Super Awesome Expo.
Super Awesome Expo.
Now it's after
Yes.
the expo.
Yes.
So I guess we're not in the future anymore or in the past.
Well, we're kind of in the past. Because you have
Just by a
to,
little bit,
you always
though.
have to record before.
Well, right, but we're like in the normal amount of past instead of like,
Yes.
2 or 3 weeks in the past talking about the future after we get back from the
I think
expo.
you're complicating things.
Our weight CNT, the value that we're passing, is very low at the moment.
Yeah. And previously it was very big. It probably wrapped around.
Oh, could have. So we did just come back from the illustrious Parallax Expo. That was actually, gosh, I don't know.
Oh my gosh, were there a lot of
Last
kids
week?
there?
There are, the supposed final count is somewhere around 2,000.
Yeah.
Yeah.
Lots and lots of people were there.
So 1,400 folks reserved, like RSVP'd, but 2,000 showed up.
Yeah, well, apparently there was like a mention of it on the local radio or news show or something, and people just started showing up in the afternoon after hearing about it.
Yep. So.
And of course, Ken and the gang were welcoming everyone and letting them join in the fun.
Mm-hmm.
So.
And so Whisker and I got a chance to take our cameras around to the different booths that were there with folks showing off their projects and interviewing them and letting them give us or their spiel, I should say. So we got to meet, I think it's Bill Henning.
Mm-hmm.
Bill Henning and his wife. Got to meet Ray from Ray's Logic.
Rayman on
say again?
forums. Rayman
on the forums. I got to meet Jack Gouge-Smith of ProPedal. And Joe Grand, of course. We got to spend quite a bit of time with him with his laser rangefinder and Game Boy printer. And
Kenichi Kato?
yeah, Kenichi Kato from, he currently resides in Singapore. And I was very impressed with theirs because they actually made quite a nice little robot that's got programmed emotions. But I asked him if it was just him and his wife, and he said, yeah, pretty much. So,
yeah, that robot was pretty cool. It would sit there and tell
impressive.
stories.
Yeah.
Did they say whether or not the robot was controlled with a propeller or not? Or?
Mm-hmm. Yep.
Yeah.
Oh, okay.
Yep.
Because I went to their website after you mentioned them, and I couldn't find. They didn't have details on the technical.
Two
side.
propellers actually.
Oh,
So
that's cool.
Yeah.
It's kind of neat watching the robot like move around and dance around as it was telling a story.
Yeah.
I
So that
saw
was
the video on their webpage.
That was quite impressive. And then there's this other guy, M. Oh man, I wish I had his card in front, but he had this magnetic submarine. And
I saw that.
yeah, very cool, and all the kids really liked it. And I managed to get a video of a kid doing that. I was like, "Excuse me, do you mind if I take footage of you doing that?" And she's like, "Okay." So
it's like a little fish tank with big electromagnets around the outside, and inside was a little submarine, little metal submarine, basically, that the magnets would cause it to go up and down and move around inside the fish tank.
Yep.
And
So I have a question. Then does that mean that the propeller can somehow, like, how do you track
Well,
within
it's
a field, a magnetic field?
You're not really tracking it. You're not getting feedback off of it in this particular circumstance. You probably could, but it's essentially the same exact thing as the motor driver that John S. helped me design for our Robo Jib.
Okay.
It's just doing pulse width modulation on an H bridge, but he's using more than one H bridge.
Right. It's actually almost akin to doing servos, right? So it's like each side of the tank has a servo moving the thing, but it's a magnetic force pushing it instead of an actual arm.
Well, servo would indicate that there's some sort of feedback, and there isn't in this case.
Well, there's no feedback, but he's definitely able to control the position, the signal, like the magnetic signal front to back on one side and up and down on the other side and right and left. And you're basically, moving the electromagnetic signal back and forth along the side.
Wait,
of
so
the thing.
he's controlling the electromagnetism of like the field?
Yeah, well, he's turning the electromagnets on and off very quickly with pulse width modulation.
Right.
That's pretty impressive.
And there's 6 electromagnets, one on each side of the cube.
Right.
Yeah.
And so he turns the two on either, like the two opposite each other. If you turn one on more often than the other one, then
it'll
the
go towards
magnetic field will be stronger on that side. And if you swap it the other way around, then the magnetic field will be stronger on the other side. So the thing will move back and forth based on the pulse width size on each side.
And this is an H-bridge design, so we are talking about polarity here.
Mm-hmm.
He can reverse the polarity of the electromagnets.
Right.
I think I want to try it.
Yeah,
I don't know about 3D, but I think at least a 2D plane might be kind of fun to try and program. I to be honest, I wouldn't even know where to start.
Well,
but
we have the technology to do it because of that H-bridge design that John helped me with.
Right, so you could just build a couple of those and hook them up to something that would produce a magnetic signal, from electricity. So you just like wrap a wire around a bolt or something like that.
Just make an inductor.
Essentially. But when you feed power through it, it'll turn it into an electromagnet. And if you pulse the power, then you can control the strength of the magnet and if you reverse the polarity, you can change the direction of the magnet. North to south portion of it. If you have multiples of those around a square, and you have a metal thing in the middle, then you ought to be able to push the metal thing around a little bit.
Very interesting. I shall try it. As of now, I am still working on the peripherals like gyroscopes and
altimeter.
Oh, yep, the altimeter module. What else have I been working on? Actually, just incorporating. Today, I just managed to get the gyroscope module to work with a RC servo and LEDs. Whoa!
Wow, you had all 3 of those going at once?
Yeah, on the prop BOE. And it's really cool because I didn't know the prop BOE, for any of you who have it. Actually, on the top above the, I'm looking at it right now, above the little breadboard section, they have these like neat servo ready locations, pin 16 through 21, I think. And at first I thought, like, I didn't know about these exactly. So I would wire each of the wires to a different pin on the breadboard,
Right.
But all you have to do is plug it in.
Right. That's a carryover from the original BOE with the basic stamp on it.
This is very exciting. Yeah. I mean, the convenience is amazing.
You can control a bunch of them at once, too.
What was that?
You can control a bunch of servos at once. There's a lot more than just one on that header there. So
I believe you can plug in 4 or 6 up there.
6. You can do 6.
You can make your own storytelling robot.
I know.
Right?
So,
and the power supply on the BOE is able to actually drive a few servos simultaneously because they built a switching power supply on there that can deliver like about an amp, I think.
Oh, nice. So then I have a question. Whisker's grunting.
But not with the USB providing the power, because USB doesn't give that much. But when you have the barrel jack or battery plugged in, then you can
drive. And that's what I realized. I had to plug in the wall wart. So my question is this, in code. So the code that I got was one that Ratronic on the forums had made. Thank you, Ratronic. It was very fun code. But this servo is running on pin 19, right?
Okay.
I find nowhere in the code pin 19. Is there like another thing that I need to look for when addressing pin 19?
Well, I'm not familiar with that particular code, but it might have like a base number that it then adds. Like they might go, okay, starting at pin 16 and then add 0 through 8 or 0 through 5 to it and get to 19 by adding to a different base number. That's probably what's going on in there. It might not say 19 directly. It might be like 16 plus some variable, and the variable might have a 3, which would make it 19.
Why would you do that?
Well, it's good coding practice, especially for demos, to include the pin up in the top in your con block, so that it's very easy for people to change it. But sometimes when you're pulling tricks, it makes it rather inconvenient to do it that way.
All right, so what do I ask? Okay, so it gives the information, the SDA pin. It gives you that. It gives you the SCL pin, right?
Right, and those are for communicating with the gyro, right?
Yeah. Yes.
Yeah. Those are the serial communication lines for the gyroscope.
And that's weird. I seem to have wired it differently, but it still works. Anyway, so
oh boy.
So
uh-oh.
Okay, so then it has write, and then it goes $D2. I'm guessing that's a particular register. Or is that a pin?
Well, yeah, what that is when you're talking to the gyroscope via the serial protocol, you have to do commands to it.
Okay.
And the D2 byte code that you send over to it is telling it you want, in this case, I believe it's to write. So you're going to write a value out into one of the registers inside of the gyroscope. So there's a protocol when you talk to these things serially that you have to follow, where the data sheet or instruction manual for the sensor will tell you, if you want to use these registers, then here's the bytes you have to send out over the serial lines to communicate with the sensor.
I see.
And that sounds like that's what that's doing.
Okay.
I believe that sensor is an I2C.
Yes, it is.
I squared C or I2C.
Yep.
So I2C is a fairly standard mechanism where you could have multiple devices on the same serial lines. And the way that you talk to a specific one is by sending its ID in the command that you send. There's a fixed
like
command
its address
structure. Right. Well, each device typically has an ID, or you could think of it as an address, but it's it's just a arbitrary ID number that gets assigned to the device. It's not necessarily arbitrary, but it's assigned. And then once you address the device with that ID, you then also have an address that you are specifying inside that particular device to say, I want to access this particular register or memory address within that particular sensor, or it could be a memory chip or, a serial communication device or something. There's all kinds of I2C things. In the case of the gyroscope, it internally has some registers that hold the results of the readings that it's constantly doing in the background.
Okay.
And so when you send a serial command, you say, I want to read the X gyroscope value, and that's in one register, and then I want to read the Y one, and that's in the next register, and stuff like that. And so you read the values out into the propeller, and then you can do stuff with them.
I have a question. Have you worked much with the gyroscope?
The particular one you're using, I've only done a very small amount of stuff with. But it's typical. It's like a typical gyroscope. The one nice thing is that it's got an I2C interface. Some of them are a little more complex in how you communicate with them. You actually have to have an ADC device and read the analog signals coming out of them.
Okay.
But
So
this one is all pre-built.
okay, so let me
I2C.
just back up a little bit. For those who do not know what I squared C or I2C is it's actually pretty. It makes sense. It's kind of this quote unquote master slave configuration where it's like you've got this main boss, a manager, so to speak, and coming from this manager, it could be your microcontroller, I suppose.
It's typically called the master. There's a master-slave arrangement.
Right, that's what I just said.
Yeah, but I'm just saying you're saying manager and I'm saying master.
Yeah,
That's
but
all.
I think it's funnier to say it's a manager. So it's the manager, right? Or master, whatever. And coming from it, it has a serial clock line and a serial data line. So that's where you see the SCL and the SDA. The serial clock line kind of sets the clock for everybody. It's like the metronome for the band. And the serial data line is pretty much where the data goes through. So you can have, like, say, 4 different peripherals or different sensors along these 2 lines, and they'll be running on the same clock, the same metronome. And in terms of the data, well, for the data to know where it needs to go, each of these devices needs to be addressed appropriately, so that this data knows where it needs to go off to and what it needs to do when it gets to.
I thought we were supposed to be explaining stuff to you on this show.
Well, I know, but see, but this is research that I've done before.
Right, and the other thing that happens is, in order, you could have like multiple devices hooked up, and the only one that will respond to the commands you're sending out is the one that you specify in the command. So when you do a write command, you specify the device ID in it,
right,
and then that device will listen and take the value and store it. Or if you do a read command, similarly, the ID tells which one of the devices that's listening on those lines, hey, I want you to answer, and then that one wakes up and responds, right? It gives you back the value that you're trying to read.
Right.
And so it allows you to have multiple different devices all plugged into the same couple of I/O pins and be able to communicate with them.
So it makes
really quite handy.
Yes, it makes things very efficient. And the gyroscope module is one of these that can be a peripheral to this type of setup. Okay, so now I'm coming back to the gyroscope. I have a question.
Okay.
So it gives us the rate of change in, like, I don't know, degrees per second, right? Mm-hmm. So you move this gyroscope and it gives you the rate, and once you stop moving it, it tries to go back to 0.
Well, it's not that it's trying to go back to 0. It's always giving you the rate of rotation.
Okay.
And the rate of rotation is constantly changing if you're moving it, and as soon as you stop moving it, the rate of rotation is 0 because it's not moving.
Right. Now, I have a question. Does it give the difference? Can it give you the difference of between your destination and your origin?
Well, no. What the sensor itself is only going to tell you
the rate.
From the last time I did a sample to now, this much rotation occurred at this rate.
Okay.
Right?
Okay.
And that's what it does.
Okay.
Your software has to read that and keep track of it and make it be interesting information to you. So, like, if you want to keep track of, okay, they rotated the thing for this long at this rate, which means that it's turned this much.
Oh.
You have to keep track of it yourself.
So you had to do the math yourself.
Yes. So you'll read it many, many times and keep track of the fact, okay, well, this time I read it and it moved, 1 degree at this rate. Mm-hmm. And I'll add that into my accumulator variable that is how much it's been rotated. And I'll read it again. Oh, it didn't move this time, so I'm not going to do anything. Read it again. Okay, it moved 2 degrees this time, so I'll add that in. And you just keep adding or subtracting if it's a negative. Like if it rotated the other direction, then you would end up subtracting values back and forth.
Okay.
And you end up with the accumulated rotation by adding it yourself.
Right. Okay. So then I have a question. So then what do you do with that data?
Well, it depends on your application.
Okay. So say it's like a balancing, gosh, I don't know. Like you have a platform on a ball.
Right. So if you have a balancing, let's say the simple, like you just want to have a balancing robot or something. You know, it's got a couple wheels. So what you would do is you would detect, okay, it's rotated to the forward, you know, leaning forward a little bit. So you would feed that into your algorithm to react that would cause the wheels to turn in the opposite direction to counteract that rotation, to make it go back up to the leaning straight up, right? To balance it out.
So it's
and then when, you know, you'll typically kind of overshoot a little, and so then you'll have to you know, send signal to the motors to reverse the direction again to push it back the other way, and it's just constantly doing those slight corrections based on the gyroscope saying, oh, it rotated a little bit, and then you run the motors the opposite direction to get it to right itself back up.
Okay.
And you just do that over and over again constantly, and it will keep itself balanced.
So,
and that's like an oversimplification of it. There's actually some fairly complex algorithms that they use to make that work more smoothly. If you do the basic version, you'll get a robot that balances, but it'll be all jittery.
Yeah.
Like bounce back and forth, and occasionally it'll fall over because it can't keep up.
Katharine Hepburn.
That's horrible, Whisker.
But
I love Katharine Hepburn.
But they have
why would she
they
be
have
a jittery
algorithms
robot?
like the Kalman filtering and
PID,
no PID logic, which are proportional integral differential logic.
Please
which
tell
will
me.
Allow you,
wait.
Those things can be used to.
You said the forbidden word.
Motion.
You said
a forbidden.
Yes, Kalman filters are not allowed.
I'm just saying those are things that people use to make the balancing more smooth.
Okay.
You don't have to use them. Some people prefer not to. It just depends.
So can I surmise that gyroscope modules are in fact not really a beginner's thing to work with?
Not particularly. Like the two most common cases for using a gyroscope are the balancing robot case and for telemetry or flight control, like you know, with a quadcopter, they use a gyroscope to help it stay aligned and balanced, right? And you might put a gyroscope, say, in a rocket or an airplane, and in combination with an accelerometer and maybe a compass module or something, and it could help you track the motion, you know, that rocket flew and how fast it flew and how much it turned while it was going up and stuff like that.
And I think for me, because so I've been working with the altimeter module, which gives altitude, temperature, and barometric pressure.
And pressure.
Yep.
That one's actually probably a little more appropriate for a beginner. Not necessarily. I mean, it's actually a pretty complex sensor and able to do a lot of interesting stuff. But if you just have the module, the code set up to read it, then you could do interesting things, like you could make a little thing that you could carry around with you on a walk and save, like every few seconds, have it save what the altitude is. And then you could tell like how much you walked up and downhill during your walk.
Right.
And that would be kind of an easy, interesting project for you to do. And you could save that data, and then when you get back home, you could spit it out on the serial terminal and put it into, you know, Excel or something.
Right.
The numbers, and look at it as a graph and see, you know, what you how hard you worked walking up and down hill at your house.
Right. And just to, so it actually was a leap, because to me, when I looked at this gyroscope module, I was like, oh, it'll be just like the altimeter module. I'll get some information, you know, blah, blah, blah. But actually, so the altimeter module, like what Roy was saying, is you get the information, and that is pretty much it. I mean, obviously you can combine it with different sensors and different things to provide feedback. But at the end of the day, you can make a nice, cute little project with that. With the gyroscope module, it took a little bit of thought shifting, or I don't know what the word, brain shifting, to realize that with the gyroscope itself, the data that I was getting was relatively useless to me. Because because if I get a rate, I'm not going to do anything with that rate.
It's not useful in of itself. You have to
interface
do some work with it. You have to store the data and keep track of it and use that information to help you feed into something else.
Right.
It's not necessarily useful all by itself.
Right.
You usually use it in combination with something.
Yeah, you're not interested in the value. You're interested in the delta.
Well, and that's different. See, that's different than other modules that I've been working with.
Right.
Because
another module that you should probably look into, which I think you have one, is a digital compass, because that's going to be really similar to the altimeter.
Maybe I'll do that next one.
It's just going to tell you like which way you're facing, on a compass.
And the other module that I have worked with is the GPS. So that too is like the altimeter module, in that the information that you get can directly be used for work. It's just it's just
your
information,
location, longitude and latitude and whatnot. It's all very straightforward stuff.
Right. And actually that one I highly recommend for any beginners to check out and to mess around with, because the object is actually quite well written, and it's really easy to make code for it as a beginner, because it's very modular and such. The gyroscope is a bit more confusing, to be honest, and I ignored a lot of the information as well as the altimeter, but
I think part of it is just that you're used to one mechanism of working with sensors, and the gyroscope is really a different paradigm. It's a different mechanism for how you use it. And you also probably just haven't thought of an interesting use for it yet.
The gyroscope?
You might come up with something that would be more applicable to Addie sometime in the future, and then it'll become more interesting to you.
I was thinking a bunny with floppy ears.
Plus, later on, when you're a little bit more advanced programmer and you're able to put together a little bit more complicated program to do something with that in combination with something else, then it might be more appropriate to play with that.
Yeah.
Yep.
And I
another thing you can use a gyroscope for that's actually a little bit simpler case, and this is something they use in like smartphones and tablets, is you can use it to detect that like they tapped it or touched it or moved it, right? Because you'll get the impulse of a rotation if you hit the smartphone on one side, or if you tilt it one way or the other.
What I can make? In The Rock, the movie The Rock, in the where they go up, the Marines go up in that little shower scene, and there's that little ball with the sensor there that they have to move so that they can infiltrate Alcatraz. I could totally make one of those. There's no sewer grate in our area, but I can be like, if Whisker touches my desk, I will know.
Right. You'll probably want, in most cases, you'll probably want to have an accelerometer also. So you have an accelerometer and a gyroscope, both connected and communicating.
Now we're just making things more complicated.
Well, it's a little bit more complicated, but once you've got them both hooked up and you're reading the data from them and you've got a little bit of code to correlate them with each other, then the results are a little more like what you want, where you could just say, okay, the device that has these two things on it is rotated this much or leaning this way. And you could actually use that to be like, detect that something happened, or to, it's a little more like what you would expect the output to be once you've what they call fused those two sensors together in a way with some algorithm. Then, like I said, you get a little bit more what you're used to. The
Right.
results are something directly useful. It's like this thing is tilted 30 degrees to the right,
Right.
or it's upside down, or it's
Yeah.
you dropped it on the floor and caused a bang,
Well, and to be honest, I would have liked if the gyroscope had shown the difference between, like, the actual difference, not just the rate.
Yeah. Well, it's not too much code, to get you the difference. It's just that with a gyroscope by itself, there's a issue of drift
Mm-hmm.
that you really can't solve just within the gyroscope. You need some other thing like an accelerometer in combination so that you can figure out, okay, it's, you combine the readings from both of them and it helps you eliminate the drift problem.
Sure.
Because
before you get too in depth on that, Roy, we are out of time this week, and that sounds like a nice deep topic that you're swimming towards over there. So I'm gonna have to stop you before you get into that. But so did you get anything useful out of that, Addie?
Yeah, I did. It's gonna have to be a little bit more complex before it becomes more easier for me to understand.
The more you know, right?
Right.
So no, that's fine. So I do have a question. I know we're like out of time.
No, we don't have any time for any of your questions.
All right.
You're gonna have to save it for next week.
Next time. Okay.
Yeah, we can start off the show with that next week. Just
I can do that.
Take a note.
Okay. All right.
All right. Well, we'll be back next week. Till then, you can listen to all of the episodes and all of the crazy questions that Addie's asked us over the last few months at firstspin.tv. We put up the show every Tuesday.
Yep.
Yeah.
And if you have any questions, just put them in the comments and we'll see if we can address them.
Yeah.
And keep an eye out for Toymaker's Expo coverage on all their other stuff.
Absolutely.
Yeah, follow links back to Toymaker Television. We'll be putting up a lot of video from the expo.
It'll be exciting.
All right. Until next week, back up off this Adrianus Mullins and Herman Shoot.
What?
See you later, folks.
Ciao.